All right, so again, we're talking about problem set 6. I noticed that Robert raised a good question. The vanilla code as is don't have any, you know, input to drive these functions and classes. So what happened is there's actually a main function that's missing in the object code. So I apologize for that. This is the code that you guys need to run the simulation once you implement all these functions, right? So so yeah, that is the important piece that's missing. So if I run that now, and you can see it will have some error, unsupported, blah, blah, blah. What is it? So in line 158, so let's see, 158. Is this something that we implemented last class? I guess not implemented, but just illustrated, right? We didn't finish that. So
Possibly.
yeah,
I'm
yeah.
scrolling up to mine.
Yeah. Let's see, 158, copy. I mean,
Yeah, I did mine a little different. I did two for statements, but it's pretty much the same thing from what I am seeing.
oh yeah, I think there's actual thing here that's not there. That shouldn't be there. So yeah, this is iterated through all the viruses and clear, remove virus. So if it's clear, you just remove it. Otherwise, you can reproduce the virus with the popular density properties, and because this reproduce has some probability, right? You probably so if it does reproduce, then you just append that new virus to that list of viruses. So that's the logic here. So now if I run it, it should let's see, same thing. Non-type. Oh yeah, because these two functions haven't been implemented, so you have to jump to definition. Yeah, because
Yeah,
these are not.
we didn't do this part last time.
We have to return something, right?
Hmm. Which is
Self dot.
the length.
Oh, sorry.
I think that's what it is. I gotta try to find. I have
Max.
mine pulled up too.
There's a max population. Uh,
Yeah, it's
because
under patient class. So
102.
that one is return the length of self dot viruses is what I put.
So here, let's see. Yeah, length viruses. That's the. Mm, actually, no. We're talking about maximum population. Maximum population is the maximum population for patients, and the current length viruses is the current number of viruses. It should be less or equal to maximum, right?
Hmm.
Does it make sense? So you have a viruses is a list of current viruses. You're simulating it. So it's just like
Hmm.
that. Self dot max pop is equal to max pop. You that's the parameter you passed into the function to the
Yep.
constructor. So now you can return self max population. And what is our scatter max population? Just get scatter. This is very easy. Self dot uh, sorry. This is max pop. This is the length of the population. Yes, that's right. Sorry.
Okay, yeah,
Yeah,
that's what I
this
have.
makes sense. So now you have this. Why? Oh, it's my spell. So now you should be able to get this. And then it's also missing simple virus objects no attribute clear probability um, in line 63. So basically, if you do top-down approach, you just have error message and keep finishing those until
Hmm.
it's no error, right? So here we talk about answer, which is in random variable to choose with a probability you clear or not. So the key is you have a clear probability here, and then you get an answer.
Can you
single virus.
explain that line of code?
This
So you
one,
have, yeah, you have a object named answer, and so your choice is between true and false, right?
exactly.
And then what is that? What is that one? I don't understand what that one is in the middle.
Okay, so yeah, this one you need to read the documentation of random choice function, and it will give you see if you put the cursor there to give you a explanation.
Hmm.
Integer, size, and non replace. Um, yeah, but again, this function is returning the true or false, right? So
Right.
answer true or false. So basically, it says you have a probability. Uh, let's see, NP random choice. And let's take a look at the np dot random dot choice in Python. Let's see the documentation from it. Right, the manual says the so reading a documentation is also important. So if it's 1D array and the size int or tuple of integers, so it's the shape of the array, right? So if
So it's
uh,
what? It's a 1D
it's
array.
1D, so it's a 1D, so you put one. Or it's
Okay.
I think it may not if it's
B2.
no, it's a 1D for sure, right? So it's just a linear array, one dimensional. P it's optional basically. You don't need that.
Okay.
Right. So because 1D, but if you have 2Ds, the shape it could be 2 or 3. So it's like that.
Okay.
Yeah. So and then try 5, 3, uniform range of size 3. Yeah, this is for the uniform, but if you've given them a list already, a 1D array like or integer, then size is not replace true. P is none. So yeah, A is integer.
I think
Size,
think I get it.
okay. Um, so if the shape is like three-dimensional m times n times k, default is none, in which case a single value is returned. So that is not necessary. It's optional. But if you have multiple, okay. Anyway, so yeah, that's that thing. Problem. So yeah. If I simple verse has no attribute clear probability. Oh, we need to define it, isn't it? Yeah, that's like you see there's error message. You keep adding this until it's gone, right? So that's
Right.
another way of doing it. So again, you have a maximum burst probability. So it's all about randomness. So that's
S-
the two variables,
So do you
maximum.
have the uh the main code that we need at the bottom?
Yes, hold on. And then there's okay. Anyway, so that's what you need. You need the main function in the bottom.
Yeah, I
Actually,
believe
if I update it, you should be able to see it now, right? So if you refresh your code on the ps6.py, it should show up.
uh-huh. Let's see.
Hope so.
Nope, it did not.
Ah, darn it, because you already forked. You already forked to how do I see? So let me see if I copy this link, right? and I give you the link.
You know, put it in the chat.
hmm And you click on it, see if you can see the updated one.
Let's see. Yeah, it's all the way at the bottom.
hmm
Uh-huh.
So I can make announcement that you guys need this to try your code. Yes, you need a driver, right? You need a driver
Right.
to. So basically, if you look at this main function, then it's probably a good way to understand this first. So this is how you use this. So you generate a simple virus with the maximum burst probability and whatever the other one is. And you have a patient with only one virus to begin with. What's the second value? Maximum probability is 100 virus, right? And then so you just update the patient every step away. The patient has different treatment, has different population, and you just observe for 100 steps. And then finally you get the total population, the virus in that patient after 100.
So
That's for the
do we need let me see. I have two different uh sections in my code that have plotting.
mhm.
Is that correct? Or I have one way down at the bottom, and then I have one um in the
Yes,
beginning
yes.
of problem two.
The plotting is let me actually put the plotting data here.
Because another issue that I have as well is sometimes when I run it,
Mhm.
um, when I
It
try
plots up.
running the file, it doesn't even pull up like the output box. It runs it.
Mhm.
So I don't know.
Yeah, so this is I don't know if it depends on their online IDE. It may not be able to pop up a
Uh,
different box to draw stuff.
right.
It should, but again, I would recommend you use local like VS Code or some IDE in your local computer and run this locally. So it will definitely plot. Now you have to, of course, locally, you have to install this package, right? The
Yeah.
make sure it works. So yeah, it's nothing wrong with running this locally. And when I grade it, I will also run it locally to see if it works. So even though if it didn't work on the IDE online, it's okay. It's limitation of the online IDE. So
So
this
we
is,
could just drop
yeah,
this in Visual Studio.
yeah, you can do that too,
Okay.
and run it. Python is so versatile. You can run it anywhere. That's one way to put it. So and this is just providing you some code online. It's a convenient place for you to refer to,
hmm
right? Like we're talking about now, it's simple to just refer to that same place. So yeah, feel free to use any other IDEs that you like. Um, let's see. So I put some, and this commented saying is for to debugging. So you feel free to uncomment it and run the other simulations. Okay.
Okay.
So yeah, these are the things that you can use to troubleshoot or um, yeah, just for you to do. And maybe simulation without drug and with drug. It's very similar. But I mean, so basically the the treatment is trying to add a drug, right? And see how the effect on viruses. Um, while doing this, if you finish off them, just think about how this all the classes and objects are designed. Why is you need, so object-oriented programming is heavily emphasized in this class. Okay, and one thing about it is that you can think about using object or a high abstract level instead of lower level, and that will simulate. And especially when there is object that is related, like has hierarchy, right? So you have a different treatment. For example, you have a different virus that derive from the simple virus. Then if you want to modify that object a little bit, but want to inherit most of the attributes, then use a class that with hierarchy. So that's the main concept. And yeah, so that's so problem one. So there's 4 problems, right? Problem 2 should be okay. Yeah, you have a plot in problem 2 too. Yeah. Sometimes you only print one picture at a time, and if you have like a equal to input, it will pause until you hit something keyboard, and then it will print the next plot. Or it can print different pictures. I don't know if you plot twice, it will print different windows. Probably.
Um,
Anyway, let me run on my local.
yeah, I
Yeah.
tried running it on my idle. It doesn't seem to be.
Okay, let me show you what's running on my idle. So this is one simulation. Can you see it?
Hmm.
Yeah, this is idle screen, and the verb y-axis is average virus population, and x is steps. After about 50 steps, it's oscillating, but tends to be stable with 70%, 70 virus up and down, up and down.
I'll have
So
to try
yeah,
this too on Visual Studio. I'm on my desktop, so I just have Python idle on here. I don't have Visual Studio.
I have idle too, and we don't need a Visual Studio, I guess. And then this is another figure. I guess it will
Uh-huh.
pause and then print. This is from idle. Let's see. Maybe resistant virus. Oh, this is the MATLAB plot. All right. So yeah, time steps and the average total resistant virus population. So if you see this, uh, that's pretty good. So this is with the treatment, I guess. And then that's the 2 pictures. Yeah, that's 2 places that's showing. All right. Let me back to the browser. So so update function inside the treat patient is basically uh, you know at each timestamp determining how many viruses still exist, right? For each virus, look at their properties, and you're basically updating the virus inside the patients every timestamp.
Right. Uh, where's this at? What class are you under?
The treatment,
Oh, the treated patient. Okay.
treated patient. So the treated patients is based on the patient, but also
Hmm.
have prescriptions. The prescription, let's see, 362. Um,
Isn't it very similar to the update
Let me give you a
um
little more hint.
in patient?
So I can say it again.
So there's the patient class and it also wants us to update it. Is the update the code that we have in that function going to be pretty much
Ah,
the same for treated patient?
yeah, they're certainly different, right? So in patient, this is I think we implement this update in the patient. This is an update in patient.
Hmm.
So all it does is because there's no drugs, right? It's not treated yet. So all the update for the virus is its own natural birth rate or something, right? And death rate. So this is without drugs. Yes,
Mhm.
the structure should be similar, but then you have to add the fact that now you have a drugs. So that makes it a little bit more complicated. But I think the the framework is the same. Let's see. This is still the same. Nothing and the reproduce function you need to add. So instead of using pop density, you also need another. How about this? Let's just do this. So what I would do, like just copy this and go to treated patient, and then paste it there. Wait, update. So yes, you paste it there, and then you have to do some modifications. First thing is the reproduce is not just pop density anymore, right? You need a get prescriptions. So you need some prescriptions. And if it still have a new virus, you still add it to the new virus. So yeah, it's just using different reproduce function.
Yeah, mine's pretty much the same, except my for loop to remove is separated from my for loop to reproduce and add. So they're split
Ah,
up.
yeah, okay. Um,
So pretty much like I it's pretty much the same from 413 to 415. That's what I have.
so
Um
you do the two for loops. Um,
yeah, and then I made the pop density object, and then um from there I did another for loop and then the try statement and reproduced it.
okay. Well, I guess you don't need two for loop because for each virus, it's either clear or burst.
Right. So it's if else, yeah. Okay.
Yeah. And that will simplify the logic. And plus, if it's removed, you change the virus. So basically, you remove all the virus that's clear, and then you only treat. Then the things left is not removed. Then you just okay. That I think that may also do. But again, you can do it in one go. So yeah, this reproduce function is from the simple virus.
hmm It's down in class patient, I think.
Is also reproduced here.
Yeah, the update right there.
I'm looking at the reproduce function.
Oh.
Jump
Mm.
to well, there's another reproduce function, right? Simple virus. There's another virus. Where is it? Oh, is just only simple virus? Let's see. Yeah, there's a resistant virus, right? Resistant virus has a different reproduce function. That's what you're doing, right? Because if you are treating patients with drugs, the virus is developing some resistance to the drug. Okay,
Right.
so that will affect their reproduce function and update function. Wait, yeah. So that's the idea. You have drugs, then the drugs make the virus resistance to the drugs. Um, so yeah, so you can see the all in all, it's just gradually increase the complexity of the classes, right? You start from a very simple virus that naturally bursts and dead, and then you have patients that without treatment, and you let the virus reproduce in your body, and get sick, and then you get drugs introduced, which will kill the virus, but again, the virus will have resistance. So that's very similar to the real world, right?
Right.
And with some probability, you can simulate how this propagate generation after generation, and there is like a balance eventually, hopefully, in the nature to control the virus to a certain level with some. So that's the whole idea of this simulation, and along the way, you learn how to plot using the you know things. So yeah, this is very similar. Again, I think it's missing this one, so that it's very difficult. But now you have this, so just take a look at how the simulation works, right? That give you some more idea when you implement this. So if someone needs a top-down approach, like I don't want to see the tree, I want to see the forest first, right? This is the forest. So you just update and get and plot. Simulation without drug, jump to that. So these two simulations is also a key, right? So once you implement that, you should have no virus and then append some virus with some probabilities. Let's see. Yeah, you give them number of viruses start with those parameters, and you run it multiple times, get the average statistics, right? And this is population. So so each trials you have 300 population, and then everything, yeah. And you do the average and you plot them every total resistance. Yeah. So this is problem 2. I guess that's okay. Did I provide any coding problem 2 or just those things?
Just that, yeah, there's
Uh,
nothing.
that makes this yeah, I know this is more difficult because now your training wheel is taken away, right?
Yeah, exactly.
Yes. But I hope with this this video you have some training wheel back, because you can see some of the implementations, and then you may have more idea on what's going on. Yeah, admit that this is probably the most challenging. But let's see, run the simulation plot graph first for each of trials. This is iterate implement. A patient. This is instance of patient run simulation, 300 time steps. This is turn, and yours solve as persuade both trials. Okay, so for those of you who look at this video today, I think you should have a pretty good idea on how to implement this simulation without drug, and then simulation with drug. Reproduce is also a very big function. You have any question with that? Reproduce.
I mean, my thing is I have everything filled out. I just don't know if it's like written right. So it's
Okay.
kind of
Uh,
hard to like
let's
explain.
right. Okay, got you. But hopefully you can try it now, right? Because with the main function, reproduce. So let's we have like 3 minutes. Which one is more? So I give you this reproduce with drug, without drug. But now with drug, I guess you probably have some. So what's the difference, right? You still need the viruses. You need to. So instead of, so basically the key is with drug, your virus changes. So instead of the normal virus, you not get a resistant virus, right?
Right.
So still you have viruses in this list, but you append a resistant virus now instead of
The simple
normal virus,
virus. Yeah.
right? And also the patient is not a normal patient, it's a treated patient, right? And again, there is 2 steps. So let me, with interest of time, I'm giving you some hint, a lot of hint. So it's a treated patient, and you divide this step in the first 100. So it's totally 300 steps. So first half of the step, you update the patient, you add the population with resistant drug.
Right.
There is a 2 different population. One is the regular population, one is the resistant population with the list of drugs in it. And then for 150 and 300, which is a later half, let's see, what's the difference? Oh, so initially you don't have drugs, is that right? And then later on, wait. Oh, okay. So then you add the drugs after 150. So initially you are so you can, so like you are infected with the disease, right, with the virus, and then after, you go to a doctor after 150 times, and you the doctor prescribe you this this drug,
Right.
and then you update it. So that's the 2 steps. You can do it differently, but did this members here? So for each of the, for each of trials, run simulation for 50 times without the drugs, and add the prescription runs for another 150 times. At the end, plot everywhere. So this is simulating the actual patient, infected with virus, and then go to a doctor, right? And then you just plot those later on.
Okay.
So I hope that this will give you, this is a little bit involved, but yeah, you can go back and look at the videos I post later, so you don't need to worry about it down. So yeah, that's the simulation with drug and without drug, and
Okay.
that
Cool.
will help you most of the way, I guess.
Yeah. And then this is due tomorrow, I think, right?
Yeah.
That's what we said.
Yeah, but since next week is the final week, right? And you don't have any finals, so if you really want to extra some time, of course I don't recommend it, but again, just make sure that you set you give that to me before the middle of the week next week. But yeah, just make sure you can understand this. What is the reproduce function? Go ahead.
Oh, I'm sorry. I came in a little bit late and I've just been kind of creeping in the background. I had one quick question. I might have caught the edge of it. Were you saying it would be better to use like Visual Studio for this one?
Yes, be better with your own VS Code or Visual Studio inside your local computer, because online you may not have the ability to plot stuff. So I don't know, but yeah. And also I updated the driving main function so that you should be able to test it now. Project, but I will have announcement in there. So we'll have less than a minute left. I guess any other questions? That Katie?
Oh, thank you.
Yeah, I jumped in late. Did you already discuss how to, like, the instructions said you could compare it to the compiled code? How do you run the compiled code?
Oh, okay. Well, I will narrate